Hello students, this is the topic 5/6 test review. This is stuff that you need to know with problems that are similar to what you will see on your test, and I've sectioned things off by how much Desmos can help you. So you can use the information in this video to make your cheat sheet. You are allowed to make a cheat sheet that is just one whole sheet of printer paper, only one side. And remember that even if you get your answer by using Desmos, you still have to show me some sort of explanation or sketch of the graph that you've got in Desmos to show me how you knew your answer, and you do not get credit for guessing. So let's get right into it. Starting out with where Desmos cannot help you. So here we see a question that asks you to rewrite this quadratic function in vertex form and then find the vertex. My bad. All right, starting out, vertex form is when your equation looks like this. Okay, obviously this does not look like this. This does not have parentheses. This does. How do I make it look like that? Okay, I have to complete the square. So when I complete the square, I start out by putting my first term inside my first space. So x squared I get by doing x times x. Cool. Now, when I'm completing the square, I want to have the same thing on both sides of the box, on like both of the outsides of the box. I want to have the same thing out here. I want to have the same thing out there. And the way that I do that is by having the same thing in these two boxes. And the way that I get the same thing in those two boxes is by taking this middle term and splitting it up evenly. So when I split negative 4x evenly, I get negative 2x and negative 2x. So since I would have to multiply x by negative 2 to give me negative 2x, I've got a negative 2 out here. And that would also give me a negative 2 out here. Then I use what's here on the outside, negative 2 and negative 2, to give me what's on the inside. Negative 2 times negative 2 gives me positive 4. Now pause. We do not have a positive 4 out here. We have a positive 2. So I have to take away from 4 to get to 2. And I have to take away 2. So I subtract 2. Now when I'm rewriting this equation with the information that I have from the box now, I've got x minus 2 times x minus 2. And then, of course, this little guy, the minus 2 at the very end. And since I have x minus 2 times x minus 2, I can just write this as x minus 2 squared. 2. Now, my vertex form gives me the vertex. That's why it's called vertex form. My vertex is h, comma, k. So h, comma, k, finding it from this equation. H is that number that's inside the parentheses next to the minus sign. Now, if it's x minus 2, my h is going to be a positive 2. Then I have k, which is this one on the outside. It's just a minus 2. So this is my vertex, all right? This is h, the x value, and this is k, the y value. Desmos doesn't help you here. You've got to know how to do this. Moving on. Simplify. When I have I, we have an imaginary number, and Desmos does not deal with imaginary numbers. So, when I'm doing this sort of problem, 3 minus 2i squared means that I'm doing 3 minus 2i times 3 minus 2i. So whenever you see the squared, that's when you have to remember to multiply by itself. When we multiply complex numbers, we will also use the box. So I've got 3 minus 2i, 3 minus 2i. I can make my box. right? In the first space, I've got 3 times 3, which is 9. In this next space, I've got 3 times negative 2i, which is negative 6i. In this third space, I've got negative 2i times 3, which is negative 6i. And then in this last space, I've got negative 2i times negative 2i, which is positive 4i squared. Because negative 2 times negative 2 is positive 4, I times I is I squared. Once I have everything that's inside the box, I can rewrite it outside of the box. From here, 2 things have to happen. I have to make sure that I combine like terms once I get to this point. And then I also have to remember that I squared is negative 1. So I don't have to do these in order. I'm going to, but you don't have to. So I'll combine like terms, which in this case is negative 6i minus 6i. So that is negative 12i. And then I'm going to change the I squared to a negative 1. So where I saw I squared, I put a negative 1. So 9 minus 12i, positive 4 times negative 1 is negative 4. And then finally, I just need to combine these last couple of like terms, which is the 9 minus 4. 9 minus 4 is 5, and then minus 12i. I want that to write a little bit nicer. 12i. Since the 5 does not have an I, and the minus 12i has an I, they are not like terms. They do not combine, and so this is our final answer. Again, Desmos cannot help. Desmos does not deal with I. Moving on to a subtraction problem. So subtraction, the fact that this is a minus sign in between the parentheses tells you that it is subtraction. With subtraction, we have to remember that what's changing is the stuff over here, since this is what I'm subtracting. So I've got 7 minus 2i, that stays the same. Then instead of negative 3, instead of minus 3, I change it to plus 3. Instead of plus I change this to minus I. Then from here, I can combine like terms. So 7 plus 3 gives me 10. Negative 2i minus I gives me negative 3i. Now, are 10 and negative 3i like terms? No, because 10 does not have an I, while negative 3i does, and so they don't combine, so that's just it. This is our answer. Woohoo! Again, Desmos will not help you. Moving on. So here, these are problems where Desmos can kind of help you, but only at the very end. Starting out, the non-Desmos part is finding the inverse function. So when I'm finding the inverse, the first thing I'm going to do is I'm going to rewrite this f of x as y, because y is nicer to look at. My first step in these problems is to switch the x and the y. Whenever I'm finding inverses, that's always my first step. Oh, my bad. So x equals square root of y minus 7 plus 4. So notice the x is where the y was, and then the y is where the x was. Then my next big step is that I'm going to solve for y. So trying to get y alone on this side of the equal sign. Now, the order that I do things in, the order that I get rid of things, I see that this is y minus 7. So I might think, oh, let me get rid of the minus 7. Wait, y minus 7, outside of that, there's a square root. So that's in the way of the minus 7. But wait, because then we have a plus 4. And that's also in the way. So when I get a variable alone, I have to work my way outside in. Work my way from the thing that's farthest away to the thing that's closest. So what that means is I'm going to start with getting rid of the plus 4 by doing the opposite. So opposite of plus 4 is minus 4. So I'm going to do minus 4 on both sides. So that gives me x minus 4 is equal to square root of y minus 7. Then before I even deal with that minus 7, outside of the minus 7, we see a square root. And the opposite of a square root is square. So I square both sides. And so that's got me with x minus 4 squared equaling y minus 7. Then, finally, all I have left is that minus 7. So what am I going to do? Add 7 on both sides. Opposite of minus is plus. So I've got my final answer. Y equals x minus 4 squared plus 7. Now, this is not actually my final answer because here it says to include the domain restriction, which means tell me which part of the graph I'm looking at. Now, remember that domain is x. And your options, like on your test, are going to be based off of these two numbers that we see here. So your options are pretty much going to be one of 4 different options. You'll have x is greater than or equal to 4, x is less than or equal to 4, x is greater than or equal to 7, x is less than or equal to 7. So these are kind of going to be your options. And so I'm going to use Desmos to show you how you can verify which option is the correct option. So this is the original function they gave us. This is the inverse function that we found. So as you notice, there are 2 different shapes. The green one is half of a U, the top half of a sideways U, but our inverse function is a full U. We don't want the full U, we just want half. So what we have to do is we have to see which inequality that's listed here is going to give us the correct half. Now, if I'm looking at the top half of this graph, that means I don't want to look at negative numbers. I just want to look at the top half. So on this U shape, that means that I don't want to look at the left half of the graph. I want to look at the right half. So I'm looking for the inequality that's going to highlight the right half of the graph. So let's look. X less than or equal to 7, I'm working my way from the bottom up. X less than or equal to 7 gives me more than half of the graph. But it's also highlighting the left side of the graph, so I don't like that one. Not her. X is greater than or equal to 7. It gives me the right part of the graph, but it gives me less than half. So it doesn't give me exactly half. If it was exactly half, it would start in the middle. But I don't like this one. Then I look at this, okay, it's split right down the middle, but it's giving me the left side. I don't want the left side, I want the right side. And sure enough, this highlights the right side of the graph, starting from right in the middle. So when we type it in here so that we just want to see the half of the graph, we have to type it like this. But as you see, this will give us the correct half of the graph that we want to see. They're perfectly inverses of each other. So that is how you could use Desmos to check your work and help you out with the domain restriction part. Now, domain is X, so it's always going to be X. For y'all's purposes, it's always going to be greater than, and then the number that's here is the number that you see inside the parentheses. Now, I know this is -4, but remember, it always switches signs when it comes out of the parentheses. So just +4. Okay, moving on, we have the other type of inverse problem we'll see. So instead of starting with the square root, you'll also see one where we start with a squared, okay, a quadratic function. Now the steps are going to look pretty much the same. So I've got y equals x squared plus 5. And then my first step is to switch the x and the y. Okay. And here we're going to assume that this is x is greater than or equal to 0. Okay. We're assuming that this is the domain that we care about. That's what it'll tell you on the test, so you don't need to know that off the top of your head. So when I switch x and y, I've got x equals y squared plus 5. And then my next step is to solve for y. So when I solve for y, again, I see that there is a squared and there's a plus 5, but this plus 5 is farther away. So I'm going to subtract 5 on both sides because that's the opposite of plus 5. That gives me x minus 5 equals y squared. And then I want to get rid of the squared. The opposite of squared is square root. So we're going to square root both sides. And I've got y equals square root of x minus 5. Now, just like the last problem, it's going to ask for what the domain is. And kind of going based off of what we saw in the last problem, since it's talking about domain is x. I already told you guys it's going to be greater than. For you guys, it's always going to be greater than. And then the opposite sign of the number that we see in here, which since that was a -5, this is a +5. So really, this should be our answer. But I am going to show you guys how we can look at it in Desmos to verify. So again, I just typed in the function that we have here. And look, it starts at 5 and goes up forever. So I'm hoping that this inequality starts at 5 and highlights it in this direction forever. And sure enough, it does. So that's how I know that it works out. That's how I know that this answer is the right answer, because it covers this graph from side to side for the correct amount. All right, moving on to our next little section. Desmos can be of some assistance on these problems, mainly for calculating stuff, but you need at least 2 functioning brain cells rubbing together in that head of y'all's. So pay attention, and there's stuff that you are going to need to write down. So this is like a problem we did in the notes because it is a problem that you are going to see on your test. Okay, in the equation below, t is a constant. Constant just means it's a number. We don't know what that number is, but it's just a number. If the equation has 2 real solutions, list all the possible values of t. So this is the part where you have to pay attention. When it talks about the number of solutions that it has, this is how we know we are going to use the discriminant. Sorry, it's going to take me a second to write. Discriminant. All right, so with the discriminant, and you might need to make a table of this, but the number of solutions that it has tells you what inequality you're using. So remember that our discriminant is b squared minus 4ac, right? If this has two real solutions, that means that it's positive, that it's greater than 0. If it has one solution, that means that it's equal to 0. And if it has no solutions, that means that it's less than 0. So you kind of need this little table to reference, and then you need to read. You need to read the question. So let's look at our equation. So let's look for A, B, and C. So here, A is 5. B is 8. And then C, some people want to say 1 because they think T is a variable. But it's not a variable. They literally just said it's a constant. So C is just T. Then I can plug this stuff into my formula for the discriminant. So for b squared minus 4ac, my b is 8. My a is 5. And then my c is t. And then since it says two real solutions, greater than 0. Now, this is where you can use your calculator. 8 squared, you can use your calculator for that. So 8 times 8, it's 64. 4 times 5 is 20. Woohoo! And then t, and then, and I'm actually going to change these to be black also. And then I'm just solving for t, you know? So I'm solving for t. It doesn't really matter the order you do this in, guys. So I've got 64 greater than 20t, and I divide both sides by 20. So really, when I use my calculator, because 64 divided by 20 is a fraction, that gives me 3.2 is bigger than t. So really, that means that my answer choices are going to be values that are less than 3.2. So anything that is smaller than 3.2, 3.1, 3, 2.9, 2, negative 100. Those will give you two real solutions. Okay. And that's pretty much it. Moving on. Solving a square root equation. Okay, and so Desmos kind of just helps out at the end of this one. So let's just get started because it's kind of a long one. You always get tripped up on this, but it's fine. Desmos can help you out. So to start out, I always want to start out by getting the square root alone. Now on this side of the equal sign, the square root is not alone. There is a plus 3. So I'm going to get rid of that plus 3. I'm going to do minus 3 on both sides. What? So really, I've got square root of 5x minus 1 equals x minus 3. Woohoo! All right. So then, what do I want to do? I want to get rid of the square root. How do I get rid of the square root? I square. Okay? So I square both sides. Square, square. That gets rid of the square root over here. So I've got 5x minus 1 equals x minus 3 squared, which, if we recall, x minus 3 squared is just x minus 3 times x minus 3. And I can use the box to multiply that. So I've got x minus 3 times x minus 3. Here, this gives me x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So really, negative 3x minus 3x is negative 6x plus 9. And then once I get to this point, I see that this equation does not have a square root in it anymore. It is squared. If I only have squared in my equation, then the way I solve it is by setting it equal to 0. So I get rid of this stuff over here. Minus 5x plus 1. So now this is 0 equal to x squared minus 11x plus 10. When I want to solve this, there's a couple ways I can do it. There's a couple ways that you guys know how to do it at this point. So honestly, I don't care. You can use one of 3 methods. You can use graphing, you can use factoring, you can use quadratic formula. Okay, so you can either use factoring, you can either use graphing, or you can use the quadratic formula. Me, I already know what the answer is going to be. So it's what? This will be x minus 10 times x minus 1. So my answers are either x equals 10 or x equals 1. So really quickly, I'm going to show you how you could figure this out in the 3 different ways. So if you're going to factor, sorry, that's my dog's tummy. If you can hear that, his tummy's grumbling. So factoring, I'm looking at factors of a, which is 1, times c, which is 10. So factors of 10 that add to make up negative 11 is really just negative 1 times negative 10. And so if I were to use the box, yeah. And then negative 1x and then negative 10x. This would be negative 10, this would be x, this would be x, this would be negative 1. Okay, that would just, it would just give me x minus 10 and x minus 1 equals 0. And then I could see that x would either be 10 or x would either be 1. The other way of doing it would be graphing. So really quickly, we hop on over to Desmos. So I've got x squared minus 11x plus 10. All right, remember that when I'm graphing, they are just my x-intercepts. What? Okay, so this is also a way to get your solutions. If this is how you find them, then please, on your paper, sketch a picture of this graph pointing at the x-intercepts, like this is where I got them from. If you just say, I plugged it into Desmos to get these, I'm gonna riot. You're not gonna get those points. Okay. Then the other way you could do it is by using the quadratic formula. So negative b plus square root of, I'm a mess, b squared minus 4 times a times c all over 2a. And then instead of b, we put parentheses. Blech. So b is negative 11. So I'm going to put a negative 11 here. I'm going to put a negative 11 here. A is 1 because I don't see a number in front, so I just assume that that's a 1. C is 10. And then A is 1. Okay, so that gives me one of my answers, and then the other one would be I change this to a minus. Okay, so it's 3 different ways that you can figure out what your solutions are. So anyways, once you figure out your solutions, okay, once you figure them out, you have to check your solutions. You have to check them because one of these actually isn't going to be valid. So when you check your solutions, you are plugging them back into this original problem. So you are going to check that when you plug in 10, oh, I'm done, minus 1 plus 3. You're going to check that this ends up equaling x, which is 10. You are also going to check that if you replaced x with 1, that it would match up. And so when I put that into Desmos, what does that look like? Oh, I wonder. Let me show you. Okay, so I check 5 times 10 minus 1 plus 3. Does that equal 10? Yes, that is what it equals. Hooray. Now if I change that to a 1, is 5 equal to 1? No. So my valid solution is simply x equals 10. This, x equals 1, would be extraneous because it didn't even work out. Okay? So that is how you would have to do this type of problem. Moving on. This one, a little bit more straightforward. Okay, just solving for x. So I have to get the square root alone. So add 5 on both sides. Square root of 4x plus 1 equals 5. People will try to get rid of that plus 1 before they get rid of the square root. Do not touch anything that's inside of the square root until you get rid of the square root by squaring both sides. So when I square both sides, that gets rid of the square root. So that leaves me with 4x plus 1 equals 5 squared, which is 5 times 5, which is 25. Then I can subtract 1. Then I can divide by 4. And I guess if you just really wanted Desmos to help you out with, you know, the basic maths of it, like 25 minus 1, 24 divided by 4, that's really what you could use Desmos to help you with, because I do want to see you work this out by hand. I swear, if you plug this into Desmos and you're like, oh, but look, it just went through there, and this is x equals 6. That's not the point. That wouldn't count. Okay, you have to go through the process of solving the equation. Moving on. Here, Desmos got you. Okay, Desmos will hook you up with the answers. You just got to know how to use it. But first, let's revisit the attributes of a quadratic function because you have to know where to find these things. First, domain. How far side to side the graph goes. For quadratic functions, let me tell you right now, domain is always negative infinity to infinity, or all real numbers for a quadratic function. Then we've got the range. Range is how far up and down it goes. It starts from the vertex and goes up forever, or it would start from the Start from going down forever up to the vertex if the graph was upside down. Then we've got our x-intercepts. Now, it says rocks because R could stand for roots. This is zeros because zeros also means x-intercepts. Okay, roots and zeros, x-intercepts, solutions. Those all mean the same thing. All right. Sorry. Then we also have the y-intercept. Then we also have the vertex, which is h comma k. And we also have the axis of symmetry, which splits our graph exactly in half. Axis of symmetry, you'll also see it abbreviated as AOS. H, that vertex, is going to be, so the x value of the vertex is also going to tell you what the axis of symmetry is, x equals whatever that is. And then if your graph is like this, a normal U, it's going to have a minimum at the y value of the vertex. If it was upside down, it would have a maximum. Now for a square root function, we've got our domain. Okay, we've got our range. We've got our x-intercept. We've got our y-intercept, and we've also got our vertex. So let's take a look at this one. Okay, so for this function, literally just once you get this, you just plug this into Desmos and literally figure out your answers from there. Now, are you going to have to sketch it for me? Absolutely. Please make sure that you remember that you have to sketch things. What is this? X minus 3 plus 1. Minus 3 plus 1. Okay. So, when I'm looking at my domain is starting from this point here. Okay, this point is 3, 1. For a square root function, notice how this vertex, the vertex was 3, 1. I'm going to be using this 3 for my domain. Okay, domain, remember, it's my x values. It's going to the right forever, so it's greater than or equal to, and then the x value of the vertex is 3. So nice. It just starts from 3 and goes to the right forever. For my range, remember, range is y. And here, my graph is going up. So I'm going to use greater than, and then it's starting from that y, the y value of the vertex, right? So greater than or equal to 1. Then, oh no. Then it's also asking me about the x-intercept. Okay, well, it doesn't cross the x-axis, so there's no x-intercept. And it also doesn't cross the y-axis, so there's no y-intercept. How fun. And then the vertex, we already said it's 3, 1. It's this starting point. And then maximum or minimum. So there's 2 ways that you're going to see this. Maximum or minimum just generally. Now, overall, on this whole graph, it has a lowest starting point, right? It starts from this point and then it goes up forever. That would make this a minimum, okay? So this is my minimum. Overall, it's my minimum, and it's at 1 because this is the y value, okay? For maximum and minimum, remember, I only care about the y value. You are also going to see a question, a type of question that we haven't seen in a second, but it'll ask you, hey, what is the maximum or minimum, or the maximum and minimum on this interval? Pick something that makes sense. And some of you may have seen this before, some of you may have forgotten. But when we have something like this, remember that we type it into Desmos, and we do the less than or equal to x less than or equal to. So remember, please write this down. But on either side, we put the two numbers that we see. What? So nice. So here, your minimum would be that lowest point, which would be like 1.7, and your maximum would be the highest point in the shaded area, so 2.2, if you want to round it like that. But please remember that because that's important and we can't forget it. All right, we've got transformations, okay? So normally I see the equation in a format like this. I've got A, I've got H, I've got K. Now remember, I'm sorry, I'm trying to move fast. A tells me the direction it's facing. Remember that if A is positive, my graph is going up. But if A is negative, it's going to be going down. And remember that that is also called a reflection across the x-axis. The other thing that A does is tell us if we have a vertical stretch or compression. So if A is bigger than 1, or the absolute value of A, if the absolute value of A is bigger than 1, then it is a stretch, which means that it looks skinnier or taller. And if it is less than 1, it is a compression, which means that it would look fatter or shorter. So whatever helps you out there. Then we've got this. If inside I've got x plus h, it's going to move to the left by whatever that number is, whatever h is. If I've got x minus h, it's going to move to the right by h. And then finally, if I've got plus k, it's going to move up. If I've got minus k, it's going to move down. Write this down. Write this down if you have forgotten it. Okay? Looking at an example. So here, is my graph going to be going up or going down? Well, remember these first two things, we're not looking at this. These first two things have to do with A. So since 1/2 is positive, and this is explanation. This is what I want to see. Okay, this is explanation. 1/2 is positive, so that's why it's going up. Then, if I look at the absolute value of 1/2, that's just 1/2. That is smaller than 1. And so, this is a compression. Okay, because 1/2 smaller than 1. However you want to write that. I just need some sort of explanation. It can be literally a sentence like that. Some sort of explanation that shows me you know where you're getting this information from. Then for left and right, I look in here. It's x minus 3, so it moves to the right 3. And then finally, I have a plus 1 out here, so it's moving up by 1 because of the plus 1. So you have to know where you're finding this information. Now you can use Desmos definitely to help you out and to help you verify. So you could always plug this in here and be like, oh, it moved to the right 3 and it moved up 1. Huh. And it's going up. Oh, look at that. All right. But yeah. Anyways, moving on. Quadratic inequalities. We are almost done, guys. Really, you could use Desmos to help you out here. So what I would recommend seeing this is literally just typing it into Desmos. So we've got y is greater than 1/4, x minus 2 squared minus 1. All right, so literally anything that, and this is it typed in, okay? Anything that's in that blue shaded area is a solution. Anything that is on this dotted line is not a solution. Anything in the dotted line or the white area, not a solution. So really quickly, let's see, just to show you examples of things that are not. do. So let's just say this is not a solution. This one is not a solution. But if I have, whoa, solution. Oh. Solution. Okay, so if it is a solution, then I put yes. All right, but see, the ones that are in the blue are solutions. Literally any point that's in this space is a solution. Anything that is on the dotted line or inside of the white space is not a solution. And that's really all you need to know for a quadratic inequality. Hooray! Oh my gosh. But you do need to explain to me why something's a solution or not. Again, it could be because in the shaded area. That's fine. And then sketch an image for me as well. Moving on, we are going to move back to Desmos pretty quickly, but it says, what is the equation of this quadratic in vertex form? So really quickly, we are going to go to Desmos, back to Desmos. We're going to clear all this out. And when it gives me points like that, I am going to make a table. And then I'm going to put those points in the table. So my first point was -2, 17. Another point was 0, 9. And another point was 3, 12. So these are all points. When I want to make an equation from these points with a U shape, you're gonna need to write this down. You need this equation. Okay, bx squared plus bx plus c. You need this. You absolutely need this. Okay, so what this does is it tells you what A, B, and C are for this U shape. So if I were to write this down as an equation, there we go. That's my equation. Okay. So this is the equation. Now it does say that it wants it in vertex form. Remember that vertex form is ax minus h squared plus k. That is vertex form. But we already know that a is 1 because that's what they told us. And here it does show me my vertex, 1, 8. So this should be 1 and this should be 8. And look, all of these are the same thing. Okay, when I see that they overlap, that's how I know that I did something correctly and that they are the same thing. And finally, we're going to have a weird question on your test where it asks you, it gives you a picture somewhat like this, and it wants the equation for the line, it wants the equation for the parabola, and then it wants the solution to this system. So first, you're going to need to find the equations, just like we did in the last problem. Okay, and then you're going to need to find the solutions, which is where they cross. All right, so when we find the equations for the straight line, you're going to use this. For the parabola, the U shape, you are going to use this one. So let's go back to Desmos and plug those points in and see what happens. Okay, so here we see that I typed the points from the parabola into their own table, and then I used the parabola regression equation, the quadratic regression equation. And so this will give me my equation. So I will see that my equation for this is y equals 1 x squared minus 3x minus 10. Okay, that is my parabola's equation. Then I created another table with the points for the linear one. Now, pay attention. It did make it x with a little 2 and y with a little 2. So I am using that same regression equation that I wrote down. I'm just making sure that it matches the stuff that I see in the table, that it's y2 and x with a little 2 instead. But I'll see that my equation is y equals negative 3x plus 6. So these are my two equations. So where it asks you for the equations, your equation for this one is y equals negative 3x plus 6. And then for this one, it is that y equals was 1x squared minus, let me scroll up, minus 3x minus 10. Why did it do that? All right, so let's go back to that slide. All right, so these are our equations right here. These are part of the answer, okay, for the question that you'll see. Then it says to find the solutions. Now the solutions are where they cross. So here and here. So your solutions would be negative 4 comma 18 because that's where they cross here, and then 4 comma negative 6, which I know this isn't in Desmos, but if you clicked in Desmos, you would find that that's where they crossed. So let me show you 4 comma negative 6 and negative 4 comma 18. So again, this problem is basically just all Desmos, but you do need to know how to use it. Okay, and so with that, we finish our topic 5/6 review. I know it is a long video. It is literally 52 minutes long. I took more than 52 minutes out of my life to make this video, but it is so that you can make a cheat sheet, you can feel somewhat prepared because this is a long test and you do need to prepare for it. So let me know if you have any other questions. B-Day, your test is on Friday, the 6th of December, and then A-Day, your test is on Monday, the 9th of December. There will be extra credit and it will be posted on Canvas. Bye.